Hello, Mr. Mack here. In this video we're going to be solving equations when there's variables on both sides. If we look at this problem here, we can see there's an m on both sides. We've got 3m on this side of the equation, and on the right side of the equation we have 5m. Now in order to solve this, we're going to have to get those m's together, because remember, our ultimate goal is to get m equals a number. So in order to do that, because they are on opposite sides, we need to do the inverse operation to move them together. And it doesn't matter which side we move them on, but we're going to find sometimes it's easier to move one side than the other. So on this problem, I'm going to start by getting this 3m and moving it over with its buddy over here, 5m. Now if I look at this 3m, in front of it, it has a minus 3m. And so to do the inverse operation, I need to add 3m to both sides. When I do that, I'm still going to have the 24, but just like before, this 3m and negative 3m are going to cancel. They're going to make 0, and on this side I have 8m. Now I'm getting closer. In fact, I only have one more step to do. This is 8 times m, and so to get rid of 8, since it's times, I do the inverse operation, divide. And that gets rid of the 8 for me. So on this side I've got 24 divided by 8 is 3. And this side I have m. And now I have m equals 3. And we can go ahead and switch that around and write it like this, so it's a little bit more proper. So, again, to recap, when they're on opposite sides, to move one to the other side, you have to do the inverse operation. This had a minus 3m, so I had to add 3m to both sides in order to get them together. And from there, it's a one-step equation. This example is a lot like the first example. Again, we're solving for c, so we need to get our answer to look like c equals a number. And again, we have c on both sides of the equal sign. Here's the equal sign. We've got one on the left, and we've got one on the right. So our goal is going to be to get them together. Now, if you remember from the first example, to do that, we have to do the inverse operation. So what I'm going to do first is I'm going to take this c and I'm going to subtract it on both sides so that this plus c and minus c will make 0. So on this side that gives me 20. On this side I have 4c minus 1c, and really this is a 1c, we just don't write the 1, and that gives me 3c. And I still have this minus 7. From here, it's a two-step equation, something you've seen before. So next, I'm going to add 7 to both sides. Which leaves me with 27 on this side equals 3c. And finally, since it's 3 times c, the inverse operation is to divide. And again, I can switch that around. C equals 9. So that looks a little bit more proper. In this example, we're still solving for y, which means we want to get y by itself. And again, you'll notice, here's the equal sign. We've got a y on this side, and we've got a y on this side. So eventually, we're going to have to get those together using inverse operations. However, I've got parentheses on this side, which is a bad sign. It kind of stops me from doing much. So what I've got to do is I've got to take this 2 and distribute it to both the 3y and the 4, and that'll give me an equation where I don't have parentheses, and then we can play with it a little bit better. So let's go ahead and do that. 2 times 3y is 6y. 2 times negative 4 is negative 8. I did not change this side, so I'm just going to rewrite it. 5y minus 2 equals 6y minus 8. Now the parentheses are gone, so now we can get the y's together. Since the 6 is bigger, I'm going to go ahead and subtract the 5y, because it is plus 5y, even though we don't write the plus. What that does, it gets rid of the y on the left side, leaving us with negative 2 equals 6 minus 5 is 1y. And you can write a 1 if you want, but you don't need to. And this negative 8 is still there. Next, I need to get rid of this minus 8. So to do that, I'm going to do the inverse, which is add 8 to both sides. And negative 2 plus 8, since 8 is bigger, comes out to positive 6. And again, I can go ahead and rewrite that so that I got my variable first, y equals 6. This example is very similar to the last one. Again, we're trying to solve for y, get y by itself. So our answer should look like y equals. But again, here's the equal sign, and we've got a y on the left side, and we've got a y on the right side, and we've got parentheses. So just like the last example, I'm going to have to distribute first to get rid of the parentheses, and then do inverse operations to get that y by itself. So to distribute on the right, I'm going to take this 2/3, and I'm going to multiply it to the 6y and to the 15. Now to do that, we can go ahead and put 1s under the 6 and the 15 if you like, and we multiply straight across. 2 times 6 is 12, and 3 times 1 is 3, so that gives me 12 over 3y. For this one, 2 times 15 is 30, and 3 times 1 is 3, so that gives me 30 over 3. Now, I don't like these fractions. In fact, they go in nicely, so let's go ahead and divide them and make them nice whole numbers. 12 divided by 3 is 4, and 30 divided by 3 is 10. Now it's something a little nicer, and I'm going to go ahead and drop down this side, 8y minus 6. Okay, now we're ready to get the y's together so that we can isolate the y and figure out what it is. So the first thing I'm going to do is I'm going to move this, since the 8 is bigger, I'm going to move this 4y to this side. It was positive, that's why I am subtracting it. We've got to do the inverse in order to get rid of it. So on this side, 8y minus 4y, the 8 is bigger, so it's going to be positive 4y minus 6 equals, this is gone, and we have 10 on this side. Now it's a two-step equation. I'm going to add 6 to both sides. So the 6's are gone. And finally, divide by 4. Since it's 4 times y, we divide. And that leaves me with 16 divided by 4 is 4. Now, sometimes some kind of bizarre things can happen, and we're going to talk about two kind of weird things that happen. That's not very usual, it's not very common, but it does happen sometimes. In this problem, again, we've got x on both sides, and we've got parentheses. So the first thing I'm going to do is distribute this 3 to get rid of the parentheses. 3 times 4 is 12. Now, if we do the inverse operation, this is positive 3x. So if I move it to this side by subtracting, something kind of weird happens. These, of course, will cancel just like we want. But on this side, we also cancel, and we get 0 on this side, which is strange because we no longer have an x. Now, if you look what we have left over, it says 0 equals 12. This cannot be. Of course, 0 never equals 12. It's kind of a silly statement. So since this is false, that means there is no solution. And sometimes that happens. There's no number that'll work that'll make both sides equal. This last example is another case of something kind of strange happening. And again, it's not very common, but they do happen. So when I try to get x by itself, first thing I'm going to do is distribute to get rid of the parentheses. 2 times x is 2x, and 2 times 5 is positive 10. And when I try to subtract 2x on both sides, to get rid of this 2x, when I do it on this side of the equal sign, again, the x's cancel. But this time, What's left over is a true statement. 10 is always equal to 10. In this case, there are an infinite amount of solutions. In fact, any number you put in there will work. It'll make both sides the same. So the solution, we will write all real numbers. Now, what's interesting to note here, and what's kind of important here, is the last two examples, those strange things that happen when x cancels on both sides. When that happens, you either get one of two things. You get no solution or all real numbers. I'm going to come back up here to the no solution so we can kind of compare both of them. In this no solution, when we distributed and we try to get x by itself, again, the x is canceled, which kind of puts up a red flag. Something kind of weird is happening. But we get something that is false. 0 is never equal to 12. That is no solution. So again, when something's false, no solution. On the last one we just did, again, we distributed, tried to get x by itself, but we saw it canceled. But we got something that was always true. 10 is always equal to 10, and so that means it'll work for any real number. Let me kind of demonstrate that as well. If I picked a number like 7, and I plugged it into the original right up here, it doesn't really matter that it's 7, it's going to work because all numbers will make both sides equal. And let's go ahead and test that. Let me show you that works. So, instead of writing an x, I'm going to go ahead and plug in 7, and I'm just going to show you it works for 7. You can pick another number, and it should work because we know that this one now works for all real numbers. So you go ahead and pick another number after this video and test it. But for now, I'm going to pick 7, and I'm going to show you that it works. So now I've got 2 times 7, so put that in parentheses, plus 10 equals 2 times parentheses, 7 plus 5. Remember, I plugged in 7 here and here for x. So let's go ahead and work this out. 2 times 7 is 14. And on this side, 7 plus 5 is 12. If I add these two on this side, I get 24. And if I multiply these two, I get 24. It is a solution because 24 equals 24, so 7 works. Now, any number will work. So you go ahead and try any number you want and test to make sure it works.